So, good morning. It's not morning.
Good afternoon. Welcome back to Mr. Hudson's Fact Day. We're here on 516. How can I eliminate fractions with equations?
But you just lied. It's not. They wouldn't be watching it live.
Well, they might. I mean, sometimes they film a morning show. Hey, so one, we probably don't have the bandwidth for that, nor would the district like that. Two, let me ask you the question now: are we going to have another day where I sit here for a while, drink a lot of coffee, and we waste a bunch of time, or are we going to get through things? I want the realistic answer. Well, it's each person's individual choice that makes up what the class, like what happens for the class. So we have this year. Anyone still need this? I will bring it to you. Raise your hand if you need this. We have this year been working a lot with proportions, which is a fraction equal to a fraction. Right, and when we have a proportion, we know that we can cross multiply to solve situations like that. Now, what we probably don't actually realize is what we're truly doing. Right? Cross multiplication is actually obliterating both divisions at the same time. So, the reason cross multiplication looks like it does, 3/5 x over 8. Is we want to get rid of dividing by 8. How do we get rid of dividing by 8? We multiply by 8, but because we do it on one side, we got to do it on the other side. Okay. Over here, it doesn't do anything. Well, quote unquote. The 8's cancel out, and the x just becomes alone. Right? So it does something, but we really, like, it doesn't impact the x. It gets rid of the other 8. At the same time, we want to get rid of this division by 5. So we multiply by 5. And because we do it over there, we do it over here. And really what we're multiplying by, what's 8 times 5? Is 40. We've looked at both denominators at the same time and said, you know what? If I multiply by 40 on both sides, that will destroy both the 8 and the 5. If we take the route of multiplying by 40, like Xander just said, what'd you say we would have, dude? 40x. You're right, but it's 40x over 8 still, right? Because this 40 is over 1.
Therefore, it makes
this
5x.
40 is over 1. So this is 120 over 3. We're going to look at the work to make sure we know what's happening. 40x over 8.
Basically,
Oh, 5, my bad. The 3 was the numerator. It got stuck in my brain.
40 over 1.
I didn't say you had to write this down, or like I'm explaining to you what's actually happening. The magic behind the curtain. Right? So then this reduces. What's 120 divided by 5?
Wait. 6. Oh,
24. What's 40 divided by 8?
5.
Probably.
Hey, remember back when we said when we cross multiply, we just do 8 times 3 and 5 times x? 8 times 3 and 5 times x. This is why you're allowed to cross multiply. Cross multiplication isn't some magic solution trick. It is an algebraic process. We don't make you write all this out, because once we do it once, we're like, oh, the shortcut is what we actually call, you don't need to write this down either. I like to tell you guys a lot that some of it you might stick. This is called the means extremes theorem. So what that means is if we wrote this out as ratios, it is 3/5 compared to x to the 8. The extremes are the outsides, the means are the inside. That's where that name comes from. You don't need to know that, but I like to let you understand why in the world are we allowed to do this fancy math. Yeah.
I'm just wondering, when you are comparing two ratios, like with one ratio, do you do 2
Or is that just when you're saying it is 2?
I'm not sure. I can't really give you a definitive answer because I don't write them like that. That's where that name comes from, and that ties into cross multiplication. So I just wanted to like toss it in there. You research it and get back to me if you want. I'm not sure. Yeah, just not 100% sure. So that idea comes into play here. So now I would like you to please, on your regular, right? That's pretty dark. 400ths x on your graph paper. 400ths x plus 1 equals 2.2. Yes. Ah. Yeah, equations with fractions. You don't even need to put solving if you don't want. And really it's equations with fractions or decimals. But fractions are the main thing we're going to work in. And then do me a favor, since the lesson is called equations with fractions, turn that into an equation with fractions, not decimals. Right, let's practice rewriting those as. That's a marker.
I like the highlighter. You write with the highlighter.
Hey, be nice. 0.4, 0.04, made a mistake.
Should we have it all to the same thing?
What do you mean all to the same thing?
Sorry, should we have it all to the same fraction bottom?
Denominator, right? That's a good question.
So
So if I make 1 into a fraction, it's 1 over 1, right? Which is great. It's very redundant. Liam? So I have denominators of 1, 10, and 100. You got a really good point, Simon.
Oh, also, you should turn that into, is it an improper fraction?
I was pausing to hope somebody would say that. Before we do that, what Simon was asking about, we should get fractions into just fractions, not mixed, right? So Simon's saying take the mixed and make it improper. This would really be 22 tenths. Right, so go ahead and rewrite that, and we'll rewrite everything, actually. 1 over 1.
Shouldn't x be in parentheses before?
Could, doesn't have to be. Because a number right up against a variable is multiplication. So if you want to, if it would make you happier, do that. You don't have to. Up to you. Now, so let's pursue Simon's idea for a second. If I want to get these to all have the same denominator, can I just like slap a 0 onto both of those?
Yep. Well,
Is 10 over 10 still 1?
Yeah.
Yeah, can I do that?
Yeah.
Yeah, can I do this?
Yeah.
Yeah, because putting the 0 on top and bottom is just multiplying by any number over itself, right, doesn't actually change the number. Changes what it looks like, doesn't change the number. Simon?
I had 25 on my bottom since 100 divided by 4 is...
You're trying too hard. A lot of you. I'm not saying you're wrong. You're right, but you're trying too hard. I'm here to help you figure out the most efficient ways to solve these problems, and all of life's problems, really. What Simon was about to do was right. He could reduce, right? This could be 1/25th. We don't need to do that. What we can do now that we have all the same denominator is wipe them out all at once. Your left side is going to get multiplied by 100. And it will take out that denominator, take out that denominator, and since we did it on the left side, it has to happen on the right side, and it's going to take out that denominator. It will probably help you to put that 100 over a 1 to remind you it is in the numerator, and it will wipe out the same denominator. So this becomes, I'm actually going to write it in purple since this is like a new iteration, 4x plus, well, it wipes out, no.
Oh, wait.
It wipes out the denominator, but the numerator stays. It's 100. Because remember, this was 1 that got multiplied by 100.
Pretty big y-intercept.
And then 220.
That's pretty big y-intercept.
It's not the y-intercept.
But it could be.
And what x is?
Because 220 could be y.
Why does it mean y-intercept?
Can I finish equations?
It's b.
It is in the b place right now, but here's the problem. We have another constant. We have 2 different constants. So just don't even talk about that stuff right now. We're not graphing. We're solving an equation. This is not like we're just trying to look at how we make this simpler. What you're thinking is when we have 2 variables. We don't have 2 variables, right? Okay, so step away from that clip. Then yeah, we're talking about linear equations, but we're not. Right? So we're not. Elena?
I think what you should do next is subtract 100 from both sides.
I agree. We should subtract 100 from both sides. Hey, it's subtraction. I'm going to write it in red.
X is 30.
Yay!
Don't spoil the ice cream.
The ice, what?
Oh, sorry. It was our math teacher's friend.
Was there a secret about ice cream?
No. So it's just like when you say the answer and other people don't know it, it's kind of ruining the thing.
Yeah, I know. My method of saying that is like, quit telling us who dies at the end. You know, like if you're in a movie and someone's already seen it and they're like, oh, Han Solo dies at the end.
They
You'd be
told
like,
me Black Widow.
don't! Like, what? Like, you wouldn't do that.
All the kids that are
But if people don't know, they don't know if that's true or not.
Explain it.
No, it's okay. I watched the first movie and I got bored.
What do you mean the first? You mean like episode 4, the first movie? No, we stop. I cannot stop. Look, I'm saying stop to stop myself. I have to stop that conversation. We're not going down that road. Thank you, math, not Star Wars math.
X equals 3. And I told it from the beginning because I solved it pretty quickly.
If you're talking about this as a line, it's a vertical line, and there is no there is no y-intercept.
I figured it out.
Well, but when you said that, it was incorrect. So I wanted to make sure you went back and like told yourself no. Questions.
Well, I just want to make sure that what I did was fine because it was very different than what you did.
Yeah.
I just started by, because the original thing was 0.04x plus 1 equals 2.2. So I just took away 1 from both sides.
What if I take away your calculator?
Well, I didn't actually need a calculator. I was just making sure like it actually worked.
Well, that would be illegal.
So you are going to manually, without a calculator, divide by 0.04 at the end. I agree with you taking
I
away.
wasn't going to. I was going to multiply by 25.
So the other route, I'm glad you like knew that route. So yes, that'll still work. What we're looking at is like the secret passageway to destroy all fractions and or decimal places. You're right. You follow the same process, but don't ignore the secret passageway because on other problems, like fraction problems, the secret passageway is way easier than the long way with dragons and everything. Anyone play the game Clank?
Oh,
No.
yeah.
So that's
Wait,
Clank.
good game.
It is a great game.
Wait, is it a
So-
card game?
It is it's a board card game.
Yeah, I have.
Yeah, it's a tabletop game. So, hey, what Alex was saying, just to circle back to that real quick, is could we also just take away 1 from both sides, and then he said multiply by 25 because that will get us a whole, right? That will work, but that is like not the secret passageway of
1.2
easiness.
times 25?
Liam,
Do you ever use that?
what? What is? Oh, the projector screen? No, actually, we need to take it down. It is aesthetically unpleasing.
It looks stupid.
Could you technically first minus 1 and then multiply by 100?
Yeah, that's what we would want. Yeah, I said minus 1 and then multiply by. Oh no, we could. So, Alex has another really good question. Could we instead? Hold up, come back here. This is sweet. I love when you guys ask these questions that like I just jumped over. Alex is saying, could we instead go back up to what Alex said, delete all of that, go back to here, and say 0.04x equals 1.2, right? Because we subtracted 1 from both sides. Now, he said, you know, I realized the furthest out decimal place is hundredths. So he said, and then can we multiply by 100? Now, Alex was thinking multiply by 25 because that will get us to 1. But if we multiply by 100, this is 4x equals 120 and gets us right where we just were the other way. So you can also, now, when, okay, you guys you'll figure it out as we get there. Never mind. I don't even need to preface it. You'll figure it out.
Wait, what?
Nothing. I was going to tell you why it matters, but no, it doesn't. All right, solve these. Solve, actually, ignore B. Solve A, C, and D. Start with the original. I challenge you, least amount of steps possible. Since y'all are giving me crap about wasting steps. Least amount of steps, what?
I'm doing it.
Answer's not on my face.
I didn't say anything.
I showed that method for a reason. It'll make sense when we get there. So, does this make more sense that you can see it?
Yeah.
You can see me too. I can, and then I'm not distracted.
Oh, now I see why you say that.
Is subtracting 0.6 from 17.4 the easiest way to start that problem? It depends if you like subtracting decimals, I guess. Like, so really, when I say things like easy or best, that is opinion, right? Like, that is my personal opinion from my experience in my brain. You can have differing opinions. That's totally fine. Great thing about America, you can tell me I'm wrong. Now, mathematically, like, there's a right answer and there's a wrong answer, but which way is best? You can tell me I'm wrong. If you want to start with the subtraction, you could. Or, what could we multiply the whole problem by to make life a tad bit easier? 10. And this problem can turn into 21x plus 6 equals 174. And even though we still have to borrow, I'll tell you, there's less mistakes when we work with integers than when we work with decimals. So taking away 6 from 174 is somehow easier for our brain than taking away the 0.6 from the 17.4. Don't ask me why. It's just my experience of working with young people. This has less of a chance of mistake. So you do whatever you think is easiest. I'm just telling you advice from the past.
Y'all take that advice.
This becomes 21x equals, what's this subtraction get you? 168, right? If we had done it up here, it'd be 16.8, but that's up to your preference. And then what do we do, class? Divide by 21. Now there is a hack for C. I can do it in one step. Anyone know the hack that will do C in one step? C in one step.
Wait, would it be
One thing on both sides. I guess mathematically we have 2 math computations to do. Sorry, what does x turn into here real quick? 8. Oh yeah, that makes sense, because 8 times 20 is...
Yeah, that's what.
Alex, what are you thinking?
Oh wait, I was not
for C.
Work.
here? I'm still thinking.
Fair?
That's
not
2
one
steps.
step. Hazel?
Divide it by 3.
It's already being divided by 3, actually.
What do we?
Xander?
Is it divide the 30 by 3?
Oh, I
Not quite. Josh? I don't care what x equals. Patrick?
To get there, not even at the answer.
Sorry, I appreciate your answer, and it is right, but I'm not asking about the answer, I'm asking about process, right? So, Patrick? Say that differently. Don't use decimals. No, don't use mixed numbers. Use the improv. Yes! If we multiply by 3 halves, the 3 on the top wipes out the 3 on the bottom. The 2 on the bottom wipes out the 2 on the top. This turns into just x. So we also have to do that over here. Who's confused at why this works?
I'm not, but it's so good.
Reciprocal.
But
You want to answer or you're confused?
No, I don't know. Both.
So let's say that's the most excited I've ever seen anyone to say they're confused. So I was asking who's confused. When you multiply by a reciprocal, give me your attention for like, I don't know, 30 seconds to review reciprocals. If I had 2 halves of a pizza, I have the whole thing. If I have 4 quarters of a pizza, I have the whole thing. Any fraction, or number really, times its reciprocal is 1. So if I have 7/3 of 3/7, it's really messy, but it's 1. Or not really messy, but like if I try to think about it in decimals, don't. Because there's 2 different repeating decimals happening there. But any fraction times its reciprocal is 1 because this is always going to be the same number on top as it is on bottom. So this actually turns into 6/6 times x, because 3 times 2 and 2 times 3. What is 6 divided by 6? Just 1x. So then I do this over here. 90 divided by 2. This is where I said there's actually 2 computations. 45.
I can do it a different way.
So Josh is right, but I just wanted the process.
Can I do it a different way?
You gonna do it in the 2 steps?
Yeah.
Oh, you know what's up.
Can I do it in 1 step?
Yeah. What do you think?
Technically, can't we just? Oh, sorry, not technically, but can we just like cross multiply if we turn 30 into?
That's not only 1 step.
It is 1 step.
Yes.
I can do it.
We need one of those wrestling ring bells where it's like ding ding ding. Technically,
How come you can say that? But
you
I
just said it twice in your explanation.
I said
I'm
it
gonna do
1
this.
and a half times.
Now you're thinking fractions.
You need to think mixed fractions.
Technically,
That was 2 times.
I keep trying to start the same sentence, but someone keeps interrupting me. Technically, that's still only my first one. The cross multiplication step is a step. That gets me 90 and 2x. Technically, we still have to divide. Right? I know that you know the math. I know that you know that one, but what if the numbers were really difficult? We have another step to do. So I'm not just trying to give you a hard time, but if we're talking technically, cross multiplication is normally a 2-step process. Multiply and then divide. Simon.
This is technically a 2-step process, but you would multiply by 3.
Where is yeah, okay. Oh yeah. And then
you would divide by 2x, which isolates x and allows you to get 45.
you're done. It's a 2-step. Yeah, it's a 2-step process, right? Now in D, is everything a fraction? Is everything a decimal? Or what do I need to do? Do I have a volunteer that wants to help me for D?
Oh,
Alex? We kind of keep bouncing between you guys.
okay. Well, wait. So I know how to do it. Can I come up to how I did it?
Can I?
Did you do it in only 2 steps?
No.
I did mine
In 2 steps, yeah. Yeah, 2 or 3.
I did mine in 3
I-
technically.
If you need to come up, I'm just surprised you need to come up and you can't talk it out. You can. I'm not saying you
okay.
can't. I'm just.
Okay, I'll try to
Negative
talk it
6.
Oh, thank you. Seriously, good catch.
out. Okay.
Come back. 2 steps.
Subtract 1.
Yeah.
And then cross multiply. Well, does turning 1 into a fraction count as a step?
Do we need to?
Well,
so hold on. Subtract 1 was step 1, right? You told me step 1, then we do step 1. Negative. Yeah, be careful with your positives, negatives.
Yeah.
What is being done to x?
It's been dividing, but
Hold on, nobody else. Hold on, I'm processing with Alex.
I
Do you need to cross multiply?
No, I immediately know the answer, but like.
What do I need to do here?
Multiply 7 by 5.
Yeah, just multiply by 5. We don't need, you could cross multiply, but there's no need. Right, so that wipes out and becomes a single x and negative 35. Questions? So we're all pros at this? If we had a mini mastery, we'd be good to go?
Yep.
On your paper, please write down x divided by 3 plus x divided by 5 equals 16. I'll write it again, especially because that's really blurry. Did you fail the vision test yesterday? If you like blurry things, that's concerning.
I went to Dairy Queen and I got a McFlurry. Why are you so disappointed?
I don't know.
What is your last name?
Hey, be nice. I like it.
Hey, there's an 8th grader with
It's
All right, I'm deleting all of those question prompts up there because it guides you in a way I think you're ready to not be given. What things? So think this through on your you should be working on your paper. Think through what things are being done that we want to undo. How could we undo all of that at the same time? So not one thing at a time, and not make common denominators and then do, like, you know when we made the hundreds on the bottom? That was great, but we don't have to do that.
One step or two steps.
Can we just?
Arguably there are 2 computations that need done, but
Okay, yeah, I can do that.
Zane,
I feel like it has something to do with the number 15.
why do you feel that way?
Oh, okay. 3 and 5, and the last time you like multiplied denominators together or something.
X times X is X squared.
Your feeling is absolutely correct. If we multiply by 15 over 1, arguably, now there's an in-between step that eventually you will get quick enough you don't need to do. I'm going to write it. Please don't nitpick and tell me I did more than the steps I said I was going to. I'm writing this so you can think it through. This becomes 15x divided by 3, 15x divided by 5. And this we do have to do on this side. For anything like this, figure out which way the multiplication is easier. Break up your 15 into 10 and 5. Right? 16 times 10 is 160. Another 5 of those is another 80. 240.
That was quick math.
So here's the secret passageway that you're gonna be able to jump through after you practice this. What's 15 divided by 3? And 15 divided by 5?
3 and 5.
3 and 5, right? This is, sorry, other way around. 5 and 3.
Well,
This is 5x. This is 3x. When you go, give me your eyes. When you go to do this multiplication, really, we're dividing, and then we want to multiply to jump through that step, because this is going to be a common multiple of our denominator, right? Because we found the common multiple. So this 15 divided by 3, this becomes 5x. 15 divided by 5, this becomes 3x. And then we do the multiplication over here and get the 240. You eventually, pretty soon actually, like in the next week or so, will not need to think through this step. It'll be like automatic. So now,
X equals 30.
x equals 30, right?
I beat you, Xander. Dude, I've had it on my paper for like 7 minutes.
So,
some of you guys got some like pent up math anger. I don't know why, but I feel like because we mix a dozen different like elementary schools. No, like a dozen different elementary schools. This is interesting because I've never taught this class before. You are all probably one of the top students in your class, and then you're also willing to take risks because you came to Phoenix. So it's interesting when we put a bunch of those students together, the dynamic that is created. Choose two of these. Choose two of these. Write out from the original all the way through.
All the steps?
All the steps. Well, as few as you can write, but like write them all. Whatever. Oh my gosh, I keep forgetting. It's what I didn't do.
Oh, God. Did you break the path going out?
A lot of somethings.
Oh, jeez. Oh, crap.
Oh, my God.
We'll get through this real fast.
Good afternoon, Phoenix. At the class change, could I please see Kieran Knight in the office for a moment? At the class change, Kieran Knight stopped by the office.
The list of people I'm about to go through. Either say yes or no. Do you want to come up and show one of these solutions? Audrey Hudson.
No.
Bear?
Yes.
Ike.
Absolutely not.
Katie Ann.
No.
Avi?
No.
Why am I
Xander?
the one who said yes?
I would, but I'm still working it out.
Well, I'm not saying like right this moment. I'm just trying to get these people figured out.
Okay.
Yeah, okay, so we got Bear and Xander, and that might be all the time we got, but then I'll keep going if we have more time. So, Bear, are you ready to come up and do one?
Sure.
Here, take this. I'm going to clone the page real fast, so then when Xander comes up, he can just have his own page. So again, write the original, right? So write out whichever one you're doing, write it on there first. And again, yeah, click a pen, all that. All right, a lot of things for you.
Didn't he just say?
Wait.
I'm so confused.
I don't know what that is.
Oh, it's an A. Okay.
Over.
This was a disaster. What? This entire packet. I did. Oh. Are you okay? Sorry, I just turned around and Alex is staring at me.
He's trying to be polite, like when you look at the person talking.
20. 21.
Mr. Hudson, you just gave me ice. Ice? Who's ice?
That was a pretty crappy smiley face.
Mr. Hudson, you just gave me ice.
I tried to, it wouldn't lift.
I don't think
It,
this is
I
good.
lifted it up and it wouldn't finish.
Yep, double check it. Your figure 6 is the same shape we get by.
By the way,
Sorry.
Wait, time out. Stop.
Just not there.
Wait.
So, hold up. Hold up, hold up.
That's not what I want, Mr.
Hold up.
wait.
He has an eye mouth though. It looks like a. Wait, why?
147?
Wait, I fixed that.
No, wait.
I did that math, right?
Where did 147 come from?
21 times 7 times 8.
So, now I say this with absolute love because I am here to try to help Bear in more ways, and all of you. And no, sit down. Sit down. If Henry was here, I don't think he would do this, but this would be the opportunity. Now, this would be rude, but Henry could turn around and say, "Poor Bear." Because we've got a mistake here. But that's okay. Mistakes are fine. Liam, you guys are bros. You're always like doing your homework together. If you were working on homework with Bear and he did this, what would you say?
I actually have no idea how he got that. I just said the right way.
I do know how he got it, but what is your the right way?
I think. So.
I know what he did. But
I multiplied the denominators. It was so you had 21 over 1 on one side, 21 over 1 on the other side, and 10 times 21 is 210. And then you have on the other side you have 21a over 7, 21a over 3. You divide the 21, 7, 21, 3, and then you get 3a
So
plus
on
7.
pause. Put your eyes up here. When I grade through your work, this is one of those like what teachers are doing. I'm looking for how did they get the wrong answer. They're actually multiplied in the denominators, right? 21 times 7, 147. 21. He did the multiplication right, but not the multiplication we're supposed to do. As Liam was just talking through, this should become 21a over 7. We multiply in the top and then divide. 21a over 3 and then 120.
I have one complaint to make.
Okay.
The only it's kind of like the same situation that Henry was in. I literally used the thing that you had mentioned earlier in the lesson for that because you
Not
said
correctly.
But that's exactly
No, look, you have this written down.
Yes.
Do you have your 15 over a 1? And then do you have the green step showing, which I said for now we do need to write.
Boom.
As he flips his paper back over quickly.
Yes. I do not.
So, you can be as upset as you want, but I'm not going to lose any sleep over that. I'll lose sleep over my dog waking up 5 times last night. But guys, when you, and I maybe we need to like reset for a moment. Have we done an open notes test in here yet?
No.
Okay, so I think we did. Yeah, way
first,
back when.
No, but we
But
can use our
so realize everything you write down while we are together can be your aid on an assessment. And as we get into more difficult content, I am a lot more likely to say, okay, this is open notes. And by that I mean open everything. Your practice assignments that you do, the stuff we write on the ORCID sheets in class, beyond just what you do on practice. So, Xander, unfortunately, we're running out of time. I'm not going to let you come up and do one of these because we got one.
Exactly what I did anyway.
Yeah, thank you. We got one more thing I really want to go over with you guys.
Yep.
This multiplies in the numerator.
Yeah.
So, I don't care about right versus wrong. Do you now see what we should be doing?
Yes.
Okay, you sure? Is everybody comfortable with how we do like the 21 times the A, the 7 just comes, it stays, the 21 times the A, the 3 stays, and the 21 times the 10, because we're doing part A, makes 120. Sorry, 210. Guys, hey, so true confession, I think I am mildly dyslexic. More than occasionally, I write numbers in the wrong order. I know what number I'm trying to write, and I write them in the wrong order. I'm perfectly fine with that, but just realize that about me, it happens. So this becomes 3A. This becomes 7A. This is actually addition because Mr. Hudson is losing his mind. There. Hold up. We're not done. There. Do we have questions?
Oh, okay. I know what I did.
Why did I write it as a
Oh, we're not done yet. So then just hang on to it for.
I need to start doing my math notes in like color. Why? Because I'm confusing myself with like what steps.
Now the last thing I was kind of hoping to get to was this. So if on your hold up, I still technically have at least a minute. Stop putting things away. If you want to really quickly, if you're at all still iffy on this step right here, this is on your ORCID sheet. Hey, stop. We're trying to go real quick. Is multiply both sides by LCM, right? The least common multiple. The lowest, right, of the common multiples of the bottom.
LCM or LCM?
LCM, least common multiple.
Should be called first common multiple.
Yeah, probably could be. Yeah, that could work.
FCM.
Then this is show the work. Right, now here is the shortcut they're taking. Hey, give me your eyes, because otherwise your orchid sheet won't make sense. They take the shortcut, the secret passageway. They do the division and then just multiply. Right? They didn't show it. They do the division and then multiply by 3 to get 9x. They're taking that shortcut passageway. Okay, so if you go back to look at this, they're taking the secret passageway. Now I'll let you guys go. Have a great day. Someone should open the wall. That would be fantastic.
I'm opening it, not Luke.